The steel shipping container, the great gray box that moves nearly everything you own across the oceans of the world, did not exist in 1942. It would not be invented for another 14 years. And yet in 1942, the United States faced the single largest movement of material in human history. The task of picking up an army of millions of men and the mountains of food and fuel and ammunition and vehicles and equipment that army consumed, and carrying all of it across 2 oceans to fight a war on the far side of the world. An army in combat is an almost unimaginable consumer of supply. A single armored division could burn through hundreds of tons of material a day. Multiply that across the entire force America sent overseas, and you arrive at a logistical demand that had never been approached in the history of warfare. And that had to be met without the one invention that makes modern global shipping possible, the standardized container. So how did America do it? How did it move an army overseas and keep that army supplied for years across thousands of miles of ocean without the container that we now consider essential to moving anything, anywhere? The answer is a story that almost nobody tells, because the thing that solved the problem was so humble, so unglamorous, so easy to overlook, that it has been almost completely forgotten. It was not a weapon. It was not a ship exactly, though ships mattered. It was a flat wooden platform and the machine that lifted it. It was the pallet and the forklift, and together they quietly accomplished one of the most important logistical revolutions of the entire war. To understand the revolution, you have to understand the nightmare it replaced, and the nightmare had a name. It was called break bulk shipping, and it was how virtually all the world's cargo had moved for centuries. Break bulk means exactly what it sounds like. The bulk cargo is broken down into individual pieces, and every single piece is handled individually, by hand. A ship arriving at a dock full of supplies had to be unloaded one item at a time. Boxes and barrels and crates and sacks, each one lifted by longshoremen, loaded into a cargo net or sling, hoisted out of the ship's hold by a boom and winch, swung over to the dock, lowered, and then unpacked from the net and carried or wheeled to wherever it needed to go. Every box was touched by many hands. Every item was handled again and again. This process was catastrophically slow. Loading or unloading a single ship could take many days, sometimes a week or more, with gangs of men laboring around the clock in the ship's hold. And the slowness created a cascade of disasters in wartime. Ships, desperately needed to carry more supplies, sat idle at the docks for days waiting to be unloaded by hand. When every day a ship spent at a dock was a day, it was not crossing the ocean carrying cargo. Ports became hopelessly congested, jammed with ships waiting their turn and cargo piling up faster than it could be moved. The hand handling caused enormous damage as items were dropped and crushed and mishandled, and enormous pilferage as goods passing through so many hands inevitably went missing. And it consumed staggering amounts of labor, tying up huge numbers of men in the brute physical work of moving cargo piece by piece, men who were desperately needed elsewhere. Break bulk was a bottleneck strangling the entire war effort, and its cost was measured not just in time and labor, but in lives. Because supplies that could not be moved fast enough were supplies that did not reach the men who needed them. The consequences could be deadly. In the early months of the war in the Pacific, the American and Filipino forces on the Bataan Peninsula were starved into surrender in April of 1942. Their supply chain having broken down, a catastrophe that underscored with brutal clarity how urgently the whole apparatus of military supply and material handling needed to be improved. The old way of moving cargo was not merely inefficient. In a global war fought at the end of enormous ocean supply lines, it was a threat to the entire enterprise. The solution to the nightmare of break bulk was an idea so simple it sounds trivial, and yet its consequences were enormous. The idea was the unit load. Instead of handling cargo as hundreds of individual pieces, each touched many times, you would gather many pieces together into a single standardized load, and then handle that entire load as one unit, in one motion, with a machine. Stack the boxes onto a flat platform, secure them, and now, instead of 100 boxes to be lifted one at a time by hand, You have one load to be lifted once by a machine. The flat platform was the pallet, and the machine was the forklift truck, and together they transformed the whole physics of moving cargo. The pallet itself is almost absurdly simple, a flat wooden platform built with a gap underneath it, a space between an upper deck and a lower deck, or between the platform and the ground, into which the two forks of a forklift can slide. Stack your cargo on the pallet's upper surface, and the forklift slides its forks into the gap beneath, lifts the entire loaded pallet and carries it away, sets it on a truck, stacks it in a warehouse, or lowers it into a ship's hold, all in one smooth motion. The forklift truck was the essential partner, a vehicle that combined horizontal movement, driving the load from place to place, with vertical movement, lifting the load and stacking it high. One historian of the Quartermaster Corps called the forklift the culmination of half a century of effort to combine horizontal and vertical motion in a single materials handling machine, and called the forklift and pallet together the most significant and revolutionary storage development of the entire war. The genius of the unit load was multiplication. A man handling boxes by hand could move a certain tonnage in a day. A man driving a forklift, moving whole palletized loads at a time, could move vastly more, because each motion of the machine carried not one box, but an entire stack. The labor of loading and unloading was not improved by some small percentage. It was multiplied several-fold, and the labor required for a given amount of cargo was slashed. The unit load did for cargo handling what the assembly line did for manufacturing. It took a process done piece by hand and transformed it into a process done in standardized batches by machine, and the gain in speed and efficiency was of the same revolutionary magnitude. The numbers behind this revolution are genuinely staggering, and they convey how completely the pallet and forklift transformed military logistics. Consider the growth in the machines themselves. When the war began for the United States in 1941, there were something like 25,000 forklift trucks in use in the entire country, most of them in civilian industry, with the military barely using them at all. By the end of the war, the number of forklifts in military service alone had grown from roughly 10,000 to over 60,000, a six-fold increase, as the armed forces embraced the machine that made the unit load possible. And behind the forklifts came the pallets, produced in astronomical quantities. By 1945, the United States was consuming something on the order of 500 million board feet of lumber every year solely to produce pallets, an entire river of timber flowing into the flat wooden platforms that carried the war's supplies. And the payoff, measured in actual productivity, was dramatic. At the Quartermaster Corps depots that supplied the Army, the average number of tons handled per man doubled between the third quarter of 1943 and the second quarter of 1945 as palletized methods spread through the system, a doubling of human productivity in the fundamental work of moving supplies. Palletization reduced the labor required for loading and unloading operations by as much as 75%, cutting the manpower needed for a given cargo movement to a fraction of what break bulk demanded. Loading and unloading times dropped dramatically. Ships spent less time idle at the docks and more time crossing the ocean carrying cargo. Port congestion eased. Cargo damage fell because goods handled as secured unit loads were dropped and crushed far less than goods handled piece by piece, and the men freed from the brute labor of hand-handling cargo could be sent where they were needed more. The humble pallet, multiplied across every depot and port and dock in the American war effort, quietly added an enormous increment of capacity to the entire logistical system, capacity that translated directly into more supplies, reaching more troops faster. Like any technology, the pallet went through a process of refinement during the war, and one improvement in particular deserves mention, because it shows how much thought went into what looks like a trivial object. The early pallets were what is called two-way pallets, meaning a forklift could slide its forks into them from only two sides, the two ends with the openings, but not from the other two sides, which were blocked by the pallet's structure. This was a real limitation, especially when trying to load pallets tightly into the confined space of a ship's hold or a warehouse, because the forklift had to approach each pallet from the correct direction, and if a pallet was oriented the wrong way, it could not be reached. The solution was the four-way pallet, a redesign that allowed a forklift to insert its forks from any of the four sides, giving the operators enormous new flexibility in how they placed and retrieved pallets in tight spaces. A United States Navy officer named Norman Canners is credited with designing an influential four-way entry pallet, a significant improvement that made palletized handling far more practical in exactly the confined, awkward spaces, the ship's holds and packed warehouses where the war's cargo had to go. It is a small thing, the difference between a pallet you can lift from two sides and one you can lift from four, but multiplied across millions of pallet movements in cramped ship holds, it was the difference between a system that worked awkwardly and one that flowed. The four-way pallet became one of the enduring standards of the materials handling world, and it remains in universal use today, 80 years later, a direct inheritance from the wartime effort to move an army overseas. The pallet and forklift were the heart of the revolution, but they worked within a larger system of standardization and mass production that was itself essential to moving the army overseas, and the pieces reinforced one another. There were the ships themselves, above all the Liberty ships, the plain, rugged, mass-produced cargo vessels that America built in unprecedented numbers, some 2,700 of them, on assembly line principles, welding together prefabricated sections so fast that a Liberty ship could be built in a matter of weeks and in one publicity stunt in under 5 days. The Liberty ships were the vessels that carried the palletized cargo across the oceans, produced in such quantity that even with heavy losses to German submarines, the tonnage available to carry supplies kept growing. And there was the standardization of the packaging itself, the effort to design the crates and boxes and containers in which supplies traveled so that they would stack efficiently onto pallets, resist the weather and the rough handling of an ocean voyage, and protect their contents. The war drove a great push toward standardized, weatherproof, efficiently stackable packaging, moving away from the miscellaneous assortment of boxes and barrels that had characterized breakbulk toward containers designed as part of a system. The famous jerry can, the standardized fuel container copied from a German design, is one example, a rugged, stackable, standardized vessel that replaced the leaky, wasteful fuel cans America had started the war with. Across the whole supply system, the war pushed relentlessly toward standardization, toward designing the boxes and cans and platforms and ships as parts of an integrated system rather than as unrelated pieces, because standardization was what allowed the machines, the forklifts and cranes, to handle the cargo efficiently. The unit load only worked if the units were standardized, and so the whole apparatus of military supply moved piece by piece toward the standardization that would eventually, after the war, culminate in the shipping container itself. The story has an epilogue that connects it directly to the world we live in now, because the wartime revolution in cargo handling pointed straight toward the container that would follow. The pallet and the unit load had proven decisively that handling cargo in standardized batches by machine was vastly superior to handling it piece by hand. The logic of that lesson did not stop at the pallet. If gathering boxes onto a pallet and handling the pallet as a unit was good, then gathering pallets into a larger sealed box and handling that box as an even bigger unit would be better still. The military itself took this next step in the years right after the war, developing standardized reusable steel shipping containers, the transporter, and then the famous Conex box, short for Container Express, which the Army used in the Korean War and after to ship supplies overseas as sealed, standardized, stackable units, a direct descendant of the wartime unit load thinking. And it was a trucking entrepreneur named Malcolm McLean who, in 1956, took the concept to its full conclusion with the modern intermodal shipping container, the standardized steel box designed to move seamlessly between ship and truck and train, which went on to revolutionize global trade and reshape the entire world economy. But the intellectual foundation of that revolution, the fundamental insight that cargo should be handled in standardized unit loads by machine rather than piece by hand, had been laid down in the depots and ports and shipholds of the Second World War by the humble pallet and the forklift that lifted it. The container did not spring from nowhere in 1956. It was the culmination of a revolution that had begun when America, facing the need to move an army overseas without containers, discovered the power of the unit load. The lesson of this story is a lesson about where decisive advantages hide and about how the least glamorous innovations are often the most important. When we think about what won the war, we think about the tanks and the aircraft and the ships and the bomb, the dramatic machines of destruction. We do not think about a flat wooden platform, and yet the flat wooden platform and the forklift that lifted it may have contributed as much to victory as many of the weapons, because they solved the fundamental problem on which everything else depended, the problem of moving the mountains of supply that an army in the field consumed. A tank that cannot be supplied with fuel and ammunition is useless. An army that cannot be fed cannot fight. And the pallet and forklift were what allowed the supplies to flow in the quantities and at the speed that a global war demanded across the oceans, through the ports, to the front. This is the recurring truth of military logistics, that the unglamorous business of moving and supplying an army is as decisive as the glamorous business of fighting, and often more so. Amateurs talk about tactics, the old saying goes, while professionals talk about logistics. America moved an army overseas and kept it supplied across the widest oceans in the world for years of war without the shipping container that we now consider indispensable. And it did so by discovering and embracing the power of the unit load, the pallet, and the forklift, the standardized batch handled by machine. It was not a weapon, and it won no medals, and it appears in almost no histories of the war. But the wooden pallet, produced by the hundreds of millions, lifted by 60,000 forklifts, carrying the supplies of a global war, was one of the quiet engines of victory. America had no shipping containers in 1942. It had something that, for the moment, worked just as well, a flat wooden platform and the machine that lifted it, and on that humble foundation it moved an army across the world. In a war decided by what could be moved, what moved the army was not a container, but a wooden platform. The steel box that carries the world's goods today did not yet exist, and America did not wait for it. It reached instead for the simplest possible idea: gather the cargo into standardized loads and lift them by machine instead of by hand. And that idea, humble as it was, multiplied the capacity of every dock and depot and ship in the entire war effort. The pallet and the forklift did not look like war-winning technology. They looked like something you would find in a warehouse, which is exactly what they were. But they solved the problem that everything else depended on, the problem of moving enough, fast enough, across oceans, to keep an army of millions fighting at the far end of the longest supply lines in history. America had no shipping containers in 1942. It had the unit load, and the unit load was enough to move an army overseas and supply it all the way to victory. In a war decided by what could be moved, the humble wooden pallet moved the war.